Hey, in this video, we're going to do a deep dive into Traversal Pro. We're going to talk about its features, and I'm going to go over the various components and settings you'll find, and then we'll do some examples of how you might add in your own features. And in the background, I'll be kind of just running around this playground scene. And this playground scene is included in the package, by the way. So, what are some of the main features of Traversal Pro? For starters, it's totally physics-based. A Traversal Pro character is just a rigid body and a capsule collider with a bunch of other components just applying physics forces. So it's not like a crazy framework that you have to go all in on. You can, for the most part, remove any components that you don't need and just write new components if you want to add in features. So later I'll show an example of like a jetpack, and for the jetpack all you have to do is just apply some upward acceleration to the rigid body. You don't need to reference anything in Traversal Pro or tell Traversal Pro anything. So that's kind of the modularity of this system at work there. So another big thing, as you kind of saw up there, is there's automatic moving platform support. So this Traversal Pro character I'm using right now, yeah, and this just crashed. It's pretty cool. This is a dynamic rigid body, this train right here. And there's nothing, like there's no scripts on this train telling Traversal Pro that the train is like a valid moving platform. Nothing about it, needs to alert Traversal Pro about its movement or anything like that. This character simply is just checking, what are you standing on? What is the velocity of the thing you're standing on? And it moves along with it. I can restart this scene to get that train back. Here, I'll run around and see if I can make it on. Oh, there we go. So I'll just sit still. The camera will rotate with the platform that you're on. And the character's mesh will rotate as well. And you can see this other guy. This is just like a non-player character. He doesn't do anything. He just stands there. He moves around with the train. It's pretty fun. Yeah, and then the second example of the moving platform, of course, is this hovering donut. This thing is pretty fun. And again, this whole platform here is just a dynamic rigid body. I don't think it even has any scripts on it. The only script is in the gravity lift. That gravity lift is like a capsule collider trigger that applies forces to any rigid bodies inside of it. But this platform itself has no scripts on it. So this Traversal Pro character I'm controlling right now is just detecting the ground and just moving along with it, checking the velocity of the point on the ground that you're on, and considering that like it's a relative ground point, if you will. Before we go much farther, I wanted to show downloading Traversal Pro into a brand new project. Traversal Pro works in any of the render pipelines, though the sample scene is just for URP. So we go to Window, Package Manager, and then we want to come down here to My Assets. In fact, actually, I like to dock this here next to the game view. Go down to My Assets, and then you can find it in here, or you can just type in Traversal right there. Hit download. Some of this may be different for you in the future. I may rewrite some of this description, but yeah, you hit download. That'll take a second. Then we need to import to project. And you just import all this. Traversal Pro shows up as a package here in the packages folder, right here. And all of the source code is included, so you can kind of run through here and check out what's in here. You can look at all the code and the different components in here. And then notice that there's no samples tab right here. You actually have to go over here to the In Project tab. And then for some reason right now, for me at least, it shows up as two. Oh, you know what? That may be because I have it like local on my computer. I'm developing it. One of these has the samples tab. So make sure you find the right one that has the samples tab right here. And here is where you can download the sample scene if you want to. However, if all you really need is to just get a working character, you're done here. You can go in any scene and right-click, click Traversal Pro, third-person player or first-person player, and you're good to go. But if you want to check out the sample scene, then we'll just click Import here. Great. Then we can go to, once this is done, Project. And it's going to show up in the Samples folder, Traversal Pro. The version number may be different for you in the future. And then Playground, and it should be right here, this playground scene. And once you open it for the first time, it's probably going to load shaders and stuff. It may look invisible for a minute as it loads up the shaders. And again, this scene is in URP. So if you're trying to open the scene up in the built-in pipeline or in the HDRP pipeline, it will probably be pink. Now let's get back into the sample scene and start looking through the components. So this right here, this player setup right here, this is kind of unique to the sample scene. I'll show you later how you can really easily just like spawn in a character. Actually, you know what? No, I'll show that now, actually. We'll deactivate this right here. That's the kind of built-in one to the scene. I'll deactivate that and I'll show you what it looks like when you just create a brand new character. How about we'll create him right here. So all you got to do to create a new character is you just right-click in the hierarchy, go to Traversal Pro, then you can choose first or third person. I'll go first person since I just showed off some third person stuff. Make sure he's snapped onto this ground. And then, which way is he looking right now? He's looking that way. That'll work. Let's check it out. And then you just hit play. And then, yeah. Camera and controls just work out of the box. Keyboard and mouse work out of the box. Gamepad. Right now I'm using a gamepad. I'm using an Xbox controller. I'll set this down actually. So now I'm using the keyboard and mouse, and I am not a PC player. I'm a console player. So this is awkward for me, but it works. It's there. Keyboard and mouse control. There we go. Can't believe I just made that jump. All right, I'm going to go back to gamepad. Yeah, and this is first person. So there's third person and first person, both available. Jump on here. Oh. Yeah, so, and then let's check out, I'm going to just delete that. Let's check out the third person one. It's going to be just the same as before, as what we saw. So that's what it looks like when you just add in a new character to a scene. And there was nothing in this scene that like was required. That would work just the same in a brand new empty scene. But I'm going to delete this guy for now. Another kind of cool feature about the player built into the sample scene is that it has a perspective switcher. So I can press pause, switch perspective. So if you need that in your game, you can kind of use this example in the sample scene. You can switch back to the third person, switch in midair. And this restart button just reloads the level. So let's go through some of the components and kind of check out what's going on. So the root, actually, you know what? Hold on. I wanted to do this with a brand new kind of default one. Let's look at the third person. We'll move him up here. All right, so this root game object doesn't move around. You can put it anywhere. It doesn't really matter where it is. This is kind of almost like a folder, if you will, to hold kind of miscellaneous components that don't really have to do with physics exactly. It's important that there's like this root game object that's not like a child of the Rigidbody, and the reason for that is the Cinemachine component. Cinemachine camera should not be a child of the rigid body which it's following. That can cause some bugs. It would be fine if you did something like this, if you had them both as roots. Oh, whoops, not like that. If you had them both as roots in the scene, but I prefer if all of the character stuff, all of the player stuff is all under one game object. I like that better. And I have the player input, so I'm using the new Unity input system. The player input component here is the main way that I'm using Traversal Pro, but that's totally optional. All the components that read input, they just have the public method, which takes in the input action.callback context, and then I hook it up here. But you can hook up the input however you want. Right now I'm using the Unity event. This is the way that I've kind of settled on personally, that I enjoy. And then if we go down to the Rigidbody game object, this is the game object for now I have named Rigidbody. This is the one that, of course, has the Rigidbody on it, has a capsule collider on it. A Traversal Pro character at its heart is just a game object with a Rigidbody and a capsule collider. And the Rigidbody needs to have the rotation frozen, or at least that's what is expected. You can play around with that if you really want to. And then I've got several other components on here. So the character motor component, this is kind of the heart of Traversal Pro. It does ground detection, and then it will apply acceleration to the character depending on the local velocity goal that you set. So it's got a public property called local velocity goal, and you can just simply assign velocities to that, and that's going to be the goal velocity that it accelerates towards. So there's a slight difference there between like the built-in Unity character controller, where with the built-in Unity character controller, normally you would say, I think you call the move method, and you pass in velocity times time.delta time. With Traversal Pro, or with the character motor component, you don't multiply by time.delta time. You just tell it the goal velocity, and then it will apply accelerations to try to reach that. And of course, it does ground detection. You can set the layer mask for what you want to be valid ground. It will detect the slope of the ground, so you'll start to slip and slide if you're on a slope that's too steep. Here's the padding. So this is like if you're walking on kind of a bumpy ground, and for like a brief moment your character is free falling, like a 10 centimeters off the ground or something. This padding here, this is in meters, will still consider you grounded if you're just barely off the ground by less than this amount. Overhang tolerance, this is cool. Let's check this out actually. So the overhang tolerance is if you start to go off the edge of an object, this will make you slip off. Maybe it'll look better actually up here. So you can't just like hang awkwardly off the edge. You slip off. Now if I increase that to like say, I don't know, 0.35. Let's go check out. Now you will be able to hang off the edge kind of awkwardly a bit. Check this out. See, you're able to hang off here a little bit more before you slip off. And then we can turn this back down. I found 0.15 works pretty well. So now you don't have that awkward floating off of the edge. Not much, at least. Free fall. This is I'll get to that later. I have a free fall component that does a few cool things, and that's a optional reference to that to help the character motor know what's going on. Ignored colliders. This is if you have any child colliders that you want to, like, for whatever reason you don't want to use the layer mask system to like consider those not to be ground. You can just set them there like as special cases to ignore when detecting ground. If they're like a child of the player and they're always with the player, obviously you don't want those to be hit and considered ground. And then that's about it there for character motor. So the character run component is going to be a component that kind of observes the character motor component. And it is the one where you define the run speed, sprint speed, acceleration, deceleration. This is one of the components that you'll likely want to remove and write your own version to kind of get your own behavior. And what it does is it will read your input, player input, and then it will set the local velocity goal in the character motor component. And I can show you actually right over here in the player input. If we drop down the events, player move right here, you can see that right now I have character run.move input hooked up on this Rigidbody game object. There's the character, oh, where is it? Character run right there. Let's go back and double check that. Yeah, character run.move input. That's the public method. That method takes in an input action.callback context. So it's pretty simple way of hooking up input. And you can, obviously hook up whatever input you need to in your custom components to get mechanics working for your game. Yeah, and then, yeah, run speed. I can increase this, make myself run really fast. Running a little bit faster now. Bring that back down. Sprint speed. There is sprinting, so on the gamepad it's the left stick for now, but that's of course optional. It also does a kind of a cool camera effect where it'll widen the field of view when you're sprinting. That's also optional. I'll show you that real quick actually. That's here on the Cinemachine camera. If you don't like that field of view effect, you can just remove this component right here. For now, here I'll actually show increased field of view. Now that'll be kind of crazy. That's not that crazy. Let's make it crazy. When you sprint, there we go. Let's go back to normal. Yeah. So you can mess with all these fields as you're playing the game, set them, do whatever you need to. And then of course I can disable this. Okay, so now I'm sprinting and no more field of view. So, and there's most of the components in Traversal Pro are like that, where you can just remove them if you don't want them, modify them, disable them, do whatever you want, and it should be fine. Acceleration, deceleration, let's turn that down a little bit. Acceleration is for when you are wanting to speed up. So now this makes the character a bit less snappy, less sensitive. We can jam this way up here. It's hard to tell, but he got up to full speed a lot faster. If we turn up run speed, it'll be more obvious actually. So he almost oh yeah, and then deceleration. So I accelerate really fast and I decelerate pretty slow. Normally it feels better if deceleration is a greater value than acceleration. I can turn that down a little, or make that even stronger. Yeah, super high acceleration there. Let's bring that all back to default values. Cool, so ground snapping. So Traversal Pro does not teleport the player. It does not snap the player to the ground, like forcibly snap the player to the ground, like a lot of character controllers will do. That's to try to give you as much freedom as possible to write your components, add forces, do whatever you have to do. Traversal Pro should be fine with it. Now, here's the ground snapping component. It's not truly snapping. All this really does is it basically applies stronger gravity to try to avoid. Let me turn this off and I'll show you what we're trying to avoid with this. We'll turn our speed up a little bit. When you're running up a ramp or stairs, it's kind of hard to see. You can kind of catch some air. Let's go a little faster. You can catch air and kind of launch off. Usually you don't really want that kind of stuff. So ground snapping tries to detect when you're in a situation like that, and it will apply more downward acceleration. And the default value I have is 15. Is subtle, but you can crank this up to try to make it stronger. So now, oh, yeah, so now it's snapping a little better. It even kind of struggled to go up the stairs a little bit. So trying to find a balance with this value is usually pretty nice. You can kind of see right there. It's staying snap to the ground. Still kind of struggling with when we run downhill like this. Maybe that's because the max distance was too low. Let's try turning that up, see if that will make it work better. Yeah, that seemed to work a little better. I'm also like moving really fast too. That seemed to work pretty good. Increasing that max distance. Let's bring all that back to normal. So if you ever find, like if you, for example, are trying to like write a jetpack component, for example, and you're trying to apply forces, but you find that the character for some reason unexpectedly is stuck to the ground, it may be this component. You may want to grab a reference to it and disable it, like while you're trying to do something that would pick you up off the ground. Or of course, like most other things, you could just remove it, honestly, if you don't need it. If you're not moving at really high speeds, then a lot of times you don't even need that component at all. And then of course we have the jump component. This enables the jump feature, very important feature. And it's implemented as a separate component. This is not part of this main character motor component. A lot of times in character controllers it's part of the main thing, but what if you want to double jump? What if you want to jump to the side? You know, I didn't want to force the jumping to be part of character motor, so it's a separate component. So there's a cooldown duration, we can increase that. So I'm spamming the jump button. There's a cooldown, right? We can increase this to something crazy. We can jump 10 units high. That's always fun. Fun to mess around with that. Jump 100 units high. Jump way up there into the sky. It's fun to mess around like that. Bring that down to 1.5. I find that's a nice value, at least for this scene, 1.5. Grace duration, that's kind of like what you might hear as called coyote time. Increase this a little bit. So like if I run off and then I click jump, I'll still be able to jump. Okay, jump. Yep, I can still jump. I can turn this down so that way now you can't do that. Now if I try to jump after falling, can't do it anymore. So there's that. Okay, the delay. This is useful for like this animation. It gives a brief moment for the animation to get started. If we remove this delay, it kind of looks funny. If we have a greater delay, that also looks funny. So you want to time it right with your animation. 0.1 I find works good for this character and these animations. Max ground force. Okay, yeah, so let's check this out actually. So when you jump, it actually applies a force to the ground. You can kind of see that really well here. Of course, when I land, that's going to apply a force, but even when I jump, it's hard to see, but when I jump, it applies a force. Let me see here if I increase the jump height, and if I add a few more zeros to this, you can see it kind of applied a force to this when I jumped. Cool, so air control, that's another feature that's oftentimes mixed in with the main character controller component. I wanted it to be separate because not every game wants air control, or maybe you want to do it a little different. So when I jump off, when I'm in midair, I can begin controlling the character. You can kind of see that, especially if I actually turn this jump way up, we can see it even better. So no control, jump, now I begin moving, and I can get a little bit of movement midair. And then if I just disable this, okay, now I'm moving the stick, not getting anything, no movement, right? And then you can, of course, as always, you can bump this up to get kind of make it crazy. You can like really control for strong for some reason. Maybe if it was like a glider or something. This actually might be pretty useful when I show off the jetpack later. This, if we bump up this air control, might work well for the jetpack. Duration, you could limit how long you have air control. So if I jump now, so like I'm gonna go forward. Okay, now I'm moving to the left. I can't because the duration is exceeded. So you only get 1 second of air control, or whatever time you want. So I can do some air control, but then I don't have control anymore. If that works well for your game. but I like it at infinity personally for now. Let's bring those back down. So the speed is when you're controlling your character, what is your kind of goal velocity in midair. Max controllable speed is so that way if you somehow accidentally exceed your goal speed, or like even if it just goes like 5.01 speed or something like that, you still have some control. However, if something launches you really fast into the air, maybe you don't want air control. Like maybe you want the player to, if you get launched super fast, like in a horizontal direction, you don't want the character to be able to control that. So that's what this max controllable speed is for. If you get launched faster than 8 meters per second, you don't have control anymore. You can increase that, and you can increase that, of course, to whatever you want. So, okay, so free fall. Free fall is pretty cool. This does two things. It applies a gravity scaling to just this character, just this rigid body. And then, of course, free fall, you can put it on any rigid body. It doesn't have to be a character. It doesn't have to be with the character motor. It doesn't have any dependency on any of this other stuff. I believe I actually have the free fall. You know what? I lied earlier. I think I do have the free fall components on that platform to kind of modify its gravity and its terminal speed. So, but yeah, the terminal speed, that's pretty cool. So 53, so for example, in real life, a skydiver, the human body skydiving, free falling, hopefully you're safely skydiving and there's no other reason you're free falling and reaching this speed. But it's 53 meters per second is kind of the average speed, the top speed you'll reach when free falling, which I think is like 120 miles per hour. You can set this to whatever you want. So, and here's where super high jumping comes in handy again. Let's do 500. Jump way up there, and then we can actually change this to debug, and we can come up here to character motor, and we can watch the velocity somewhere around here. That prior velocity, that will work. You can actually do this built into Unity too. You can check the rigid body's velocity, I believe. There's a window somewhere. But we'll watch prior velocity, especially the Y value. Let's see, so what did I set it to? I set it to 116. That's not quite high enough. Here, let's do a test, especially for this. So we'll set the, you can do the root or the rigid body, either one. I'll set the rigid body to like 1,000. We'll go way up there. And we'll watch and just see that the terminal, we'll keep it at 53. Go to debug. And we'll watch this prior velocity and just hit play. And we're falling. We'll watch this prior velocity. It's going to slowly approach negative 53 and then pretty much stall there. Might not even reach 53. It'll probably stop at 52.999. Right? And then if I can increase this. I will restart. Not long enough. You fall too fast. We'll increase this to like 84.9. We'll see that the velocity approaches 84.9. Yeah, so if you need a terminal velocity, there you go. And then, of course, the gravity, I can show that real quick too. Come back down here. Gravity, we set the gravity to normal. So I believe this project right now has just like 9.81 gravity, the default. It feels kind of floaty. That's real. That's totally realistic gravity, right? But as is the case a lot of times in games, that feels kind of funny. Doesn't feel good. So you can always increase the project gravity. Sorry, my mouse is controlling the camera as well. Or you can just, for convenience, you can just bump this up here. Bump it up to 10. Oh, and then he struggles to even stand on a slope. It's a little faster. I find 2 is pretty nice. Roughly negative 20 for the gravity value. Cool, so let's check out the rest of this hierarchy. The view, this game object is this is where the player is looking right now. So the player's view direction, like where it's looking, which axis, which vector is forward, is simply stored in a transform. It's not stored in like a Traversal Pro component that, you know, if you write your own component and you need to know which direction the player is looking right now, there's not like a special property on a special component. It's just this transform. That's all it is. And we can see, for example, character run has a reference to the view transform, because like if you push forward and you're looking, I think that's probably Z positive, that's like north. So like if your camera's facing east and you push forward, you want to be moving east. You don't want to be moving that way, right? Because it depends on where you're looking. So that's why the character run needs to know where are you looking, so it can rotate your local input into world input. So yeah, so if you ever need to know that, it's just the transform. It's not a special component. The view control component, this reads player input and then rotates this transform. And we can watch right here these rotation values. You know, as I'm using my gamepad right stick to rotate, right? Pretty standard, like a minimum degrees. Can bump this up. So now I can't look any farther than down there. I find 85 to be kind of nice. Bring that down. So now I can't look any higher than that. And as with a lot of controllers, it doesn't work that well if you're allowed to look straight up or straight down. Let's see. I mean, it works okay, I guess, but well, I don't have any bugs right now. But a lot of times, if you're looking straight up or straight down, that can kind of confuse some stuff. So usually, right, maybe like 89.9 is safest. A lot of times. Pointer. This is so like if you need to, change the sensitivity. And these are public fields. So like if you need to, in your pause menu, adjust the gamepad or mouse sensitivity, you can just access these public fields right here on this component. And of course, if you have your own script where you want to rotate, like you have your own camera system, you can just remove this right here. Remove this component. Although I will say, look at this one next, the view rotate with ground. This component has a reference to the character motor, and it detects like whatever ground you're standing on and if it's rotating. So I'll actually disable this. So now this train is like moving and rotating, and now the camera is not rotating with it. It's just going to continue to look that way, that direction. I'll re-enable it again. Rotating the camera on a ground, that may cause some people some motion sickness. So if that's the case, if you don't like that feature, this is super easy to just disable or remove. There again, it's disabled. I can remove it. But what I was going to say was that this view rotate with ground component, it does require the view control. So if you have your own camera system, you could remove view control, but then you won't be able to use view rotate with ground. But it's not too hard to kind of implement that if you want this feature. It's a public property in character motor that you can simply read, like the ground angular velocity. It's there if you need it. Yeah, and then smooth time, you can increase this, which, I mean, you don't want it this high usually, but for some reason, if you like that, there you go. Smooth time. I like it a lot better when it's kind of snappy. Maybe 0.1. If you're playing something like, I don't know, like I think of like Resident Evil Village or something where it's kind of a slow-paced game. Maybe turn down the acceleration, bring the character run speed down to kind of a walk, sprint speed down here, and then you have something that's more of kind of a slow-paced game. And this is your sprinting right here, not very fast, right? The camera could be kind of slower. There's that like acceleration on the camera, but it's all adjustable. That's all this stuff are public fields, can be adjusted in like a pause menu. Yeah, 0.03. I like that. I think that feels pretty good there. Yeah, and then view rotate with ground also is a smooth time, like how quickly do you want this to kind of catch up? Let's bump this up so we can see what it does. So like it's going to try to match the velocity of the train, but it's going to smoothly match that velocity, and this is how long that will take. Again, I think it feels good if it's a little snappy, but not zero. Ground mass factor threshold. Okay, so that's like, okay, so here's actually something cool I can show too. And this actually kind of relates to character motor. Maybe I should have talked about this when I was talking about character motor. You can walk on stuff, and it's pretty fun. Let's get this over here. Come on. This has a capsule collider rather than a cylinder collider. That's why I was able to kind of push it around. And then you can, come on, you can hop on top. Oh, kind of walk. Now, another thing about the character motor is it applies forces to the ground. Whoa. All kinds of craziness over here. It will apply a force to the ground when you're walking forward. So if I'm walking forward, it's going to apply a force to the ground going backwards. So that's one of the reasons why this works. Ooh. So, right, and I was talking about the view rotate with ground. It can be really weird, like if you're walking on some small thing like this, and all of a sudden your camera starts rotating really crazy. I was having that problem. That was because of this component. So this field here makes it to where the ground object that you're standing on needs to have a mass that is like this many times heavier than the player in order for this rotating the camera to take effect. And of course that train has a massive mass, much larger than the player, so that works. The camera rotating works. But this is fun too. I want to make a sample scene where you can kind of like Fall Guys or something, where you're like trying to get on top of giant cylinders. That would be fun to play with. You can also do that with these spheres over here. You can walk on these. That's kind of fun. And again, the character motor is applying a force to the sphere, to the top of the sphere, to the point of the sphere that you're standing on. So of course that's makes it roll. It's kind of cool. You can see it with the cubes over here too. Oh, if I walk around in circles, it's kind of hard. You can kind of see that the stack started to as I walk around on it, the stack kind of wobbles. That's because the feet are, or rather the bottom of the capsule collider is applying a force. Oh yeah. The train can crash. Crashing the train is always fun. And even though the train is, this is completely unexpected, unpredictable, yet you can still walk on it. No way to know exactly what format this is going to, or what orientation this is going to land in. You can still walk on it. Pretty cool. You can kind of see this wobbling as I jump. The jumping is applying a force to the ground as well. Let's keep going. So velocity yaw animation. Okay, so this is, the rigid body does not rotate. The view rotates and the mesh rotates, but the rigid body does not rotate. The mesh, this component here, attempts to rotate the mesh based on the movement velocity. So, and we can bump this up too. We can increase this smooth time. Let's see here, this curve right here. I found that changing this from just a float to a curve, where the x-axis is the player's current speed and the y-axis is the smooth time, worked out a lot better. It gave me a lot more control. See, now you can see that when I'm moving forward, now I'm going to move right, and the mesh kind of slowly turns that way. I feel like this is an important feature. You don't want it to just instantly snap to the direction. It's using smooth damp. Smooth damp is just the best for a lot of stuff like this. But of course, that's too much damping, of course. So I think that's back to normal. Yeah, there we go. That looks a lot better. There is also, alternatively, I have this as well. What is it called? Yeah, smooth yaw constraint. Missing transform field on... Yeah, okay, that's because I need to assign this, of course. Right. Oh, and it's mad because I didn't have that assigned, and I'm in play mode, of course. So with a lot of this, I try to put out useful error messages if something is missing. Yeah, cool. So now this is just, it's not following the velocity, and I don't have strafing animations. I'm using the Unity robot, and it just comes with the forward animations. At some point, I hope to get some more animations in here, but if you need kind of left and right strafing animations, you'll have to find those and put them in, which is just the normal Unity Animator process. There's nothing special to do animations with Traversal Pro. Although we'll get there. I do have a component which assigns properties to the animator. But anyways, yeah, so this component attempts to make the mesh rotate towards the view direction, the orientation of this transform here, or any transform that you drag in, actually, which normally you would want it to be this. If we decrease the smooth time, this is what I find a lot of character controllers doing right here, and I hate it personally. If you like it, that's cool. But it's where the mesh rigidly follows the camera rotation. I'm not a fan of that. I like the smoothing. So if we increase that smoothing, now you can see that it doesn't rigidly follow. You turn your camera and then the mesh smoothly follows after. And we can bump that up, again, kind of to ridiculous levels, like you would never want this, but just to show that it can do it. Super high smooth time where it's very slowly rotating towards the camera. A little bit snappier is of course better here. So that's an option as well. But again, I don't have the strafing animations right now. Oh, and you can kind of actually, you kind of saw the next component I want to show. Let's bring that back. The next component I want to show is kind of cool. It's the acceleration roll animation. This, when you turn, it tries to apply a leaning rotation to the transform that it's attached to, based on the, excuse me, based on the velocity, the acceleration of the player. So it gets a reference to the character motor. And I can bump this up to exaggerate it so it's more obvious what it's doing. It looks, as with most of these things, it looks better subtle. But yeah, now you can see more obviously what it's doing. I mean, this looks kind of cool. It's just it's not doing anything with the animator. It's not animating anything. It's just rotating this transform. You can see the rotation right here on the Z value of the rotation. And this, let me see here, I'll show you. The pivot of this is up here at the head. So when you rotate it, okay, it's fighting me because it wants control of this. So if I disable this, I should be able to then. Yeah, so you can see that this transform pivot is up there, so you can rotate like that. Now if I turn this back on, it wants control back over that. Let's go to the game. Yeah, so that's kind of a cool feature. But again, of course, I've exaggerated it crazy just to show what it's doing. Let's put that back to a reasonable value. I think I had it at 10. Let's do 20 for now. You can kind of see it. And you know what? Let's turn this off so you can see. This is what it looks like without it on. It's a subtle change, but I think it looks really nice. You can kind of see him leaning into his run a little bit. Looks pretty cool. Let's hop over here to the Unity robot. Okay, and this is where we have the third-person animation. So there's the animator script, or the animator component like normal. What do we have? And then the skinned mesh renderer like normal. Yeah, and then this is a Traversal Pro component, the character animator. So what it's doing is it has a reference to the character motor component and the jump component. It reads values from these components, such as the player velocity minus the ground point velocity, because what you really want is the relative velocity, like the velocity relative to the point on the ground. So let's restart actually so you can see. Oh, I messed with something. I think I set the gravity. Let's fix that actually. Let's go back to Rigidbody, all the way down here to free fall, set this back to 2. There we go. That feels better. Let's get on here. So the character animator component is detecting right now. It's reading from the character motor. It's reading the ground point velocity, and that's a public property. You have access to that as well in any script that you need. You can read that as well. It's subtracting the rigid body linear velocity, which is, obviously not zero. We're moving right now. It's subtracting the ground point velocity from the rigid body linear velocity to decide what is the player's local movement velocity. And it's using that local movement velocity to set the appropriate values, named parameters in the animator controller asset. So that's all it's doing, which is a pretty standard approach, I think. Right? You just want to set those properties in the animator controller. And this is another script where you will, I think, most likely want to write your own. Maybe. I mean, I could definitely see keeping this for the run and jump animations, and then you could totally just write an additional script to read whatever other values you need. I don't know, climbing, shooting, whatever you're doing in your game, and assigning those to the animator as needed. Or of course, and the code is included, so it's source code is included. So you could even just copy this, honestly, the code, and edit it to do whatever you need for your animator. But for sure, this is one of the components where you'll most likely want to write your own for custom behavior in your game. So we have all these names here. This is so that it's easy to match the name to whatever name you're using in your animator for the property that you want to set. Okay, here. This is super cool. I like this a lot. This animation curve. What this does is it takes the x-axis, it takes in as input the player's speed, and then the output is going to be the value that gets sent over to the animator for the velocity, like whatever you're setting for the run animation, right? So that way you can very carefully match up movement speed to animation speed to avoid foot sliding. This curve here is all about avoiding foot sliding. So if I kind of mess this up, it's really more apparent at slow velocities too. So let's just screw it up. You can kind of see. Now you can see it. I just totally messed it up. Now we're getting lots of foot sliding at these lower velocities. Let's mess up some of these middle velocities as well. Yeah, so it's totally messed up. I went through here super carefully and tried to get these right for this animation. If you use a different animation, different rigid body, well, not rigid body, a different, really just different animation, I guess. You'll probably want to fine tune this curve for yourself to get the correct values. And if we undo that, now you can see as he walks, it's a lot better, a lot better. Not perfect, but pretty good. And again, this Unity robot only comes with forward animation. No like turning animation, turning in place, no side strafing. So it's not going to be perfect. Traversal Pro is mainly a physics package. It's not necessarily meant to be like an animator package. As you saw, like I do have some components where I try to get some cool animation effects in there, but it's primarily about physics. So getting your own mesh, your own animator, your own animations is just the normal process in Unity that you'd follow. Cool. So run velocity, smooth time. This is to kind of smooth. I use smooth damp all over the place. Kind of see it's a little jerky now. You can see the animation. Now it's just taking the velocity as is and applying it as that run speed, which kind of results in some jerky motion. That's why I really like the smooth damp there. So it'll smooth out any jerkiness in the actual physics speed when it assigns values to the animator. Recent jump duration. That's so that for this duration of seconds, 0.1, it's telling the animator that you're currently jumping after you click jump. Jump name, of course. You can hook up like audio here to footstepped and landed. Yeah, and then let's take a look at these. Yeah, so by default, it's using Cinemachine. Cinemachine is a required package for Traversal Pro. So when you install Traversal Pro, Cinemachine will get installed automatically. You don't need to worry about installing it. And that's going to be Cinemachine 3. So if you have a project where you're like making heavy use of Cinemachine 2, this will require Cinemachine 3. So just be aware of that. You may want to, if you really need Traversal Pro and you're using Cinemachine 2, just be aware of that. You may need to switch over. But you can remove Cinemachine from this player and use your own camera system if needed. Oh, cool. Yeah, this flipped over. Always fun when it flips over. Sorry, dude. We flipped your train. Let's look at, I have, yeah, I showed you the sprint effect. Here's this other component that I find really useful. And let's see. To show this off, I'm going to bring that jumping back up real high. Let's disable this. So Cinemachine provides a damping value, but it doesn't do so well when you're free falling or when you're moving fast. It can like struggle to keep up. So let's see. See how the player will leave the frame because the damping struggles, especially when you're accelerating in free fall. The damping really struggles to keep up by default. If there's something in Cinemachine that fixes that, I don't know about it, let me know. But anyways, I wrote this script to fix that. So what it does is when you're moving at certain speeds, it will reduce the damping value. So let's watch this damping value right here as I jump. It reduces it down. And that was, I bet you what it was doing just now was probably, yeah, some of the scientific notation. That's always so confusing when that scientific notation is hidden. And then you see these whole numbers right there. So here's another animation curve. Animation curves and smooth damp are just the best. They're great. So what do we got here? So the x-axis is the player speed. So, and that's in any direction, free fall, like if you're running forward, falling, any speed, the magnitude of your velocity, which is the definition of speed, I believe. X-axis is your speed, Y-axis is the multiplier to apply to the original damping value that was recorded upon start. So it saw that the original value was 0.5, and I'm holding still right now, so it's trying to get back to 0.5. Smooth damp a lot of times doesn't, get exact result, but it gets real close. And then, yeah, so as we're moving fast, it will reduce that damping now to try to solve that problem. Which is just, that's awesome, because then you can still use Cinemachine damping, even though you might be in free fall, you might be doing who knows what. I don't know what you guys do in your games. So I think for now, that's the components I have. Let's do a demo. I have already created a few scripts. Let's look at this Jetpack script to start with. This is this little tiny Jetpack script. All it does is it just grabs the Rigidbody and applies an acceleration upward. That's it. And one thing to notice here, which I think is awesome, is there's no reference to Traversal Pro. We don't have the Traversal Pro using statement, nothing. We're just doing whatever we want to the Rigidbody, and Traversal Pro will be just fine. That's what that script looks like. Let's go back over here to the Rigidbody. Let's hop back over here. And I can add in the component, Jetpack. And of course, so this script is not included in Traversal Pro. You can, I just showed you, you can copy it. I just wrote it real quick just to show off what it looks like to write a custom script and get it working with Traversal Pro. 10, actually the acceleration of 10 won't work because right now, like gravity is like -20, so you gotta beat gravity at least. So let's go 40. And then let's go up to player input. Oh, you know what? Well, while we're here, actually, I want to show you this. This is the way that I found that I really like using the input system. Whenever I have a component that needs player input, I'll just do this. I'll just write a public method that takes an input action callback context, read the value, save it up here, and then use it in update. Maybe this sounds really obvious and like stupid simple, but I know there's a lot of different workflows with the new input system. This is the one I've kind of settled on because it's so easy. I love it. So yeah, there's this public method. Let's go into player input, and I'm using the invoke Unity events kind of style of using player input. Pop open this player. Oh, and sorry, one other thing. Traversal Pro comes with a default input action that is referenced. You can, of course, write your own input action asset, or design it, I should say. There's a manually editing it by hand, and drag that in here. You don't have to use this one. It's just there as a nice starter. But let's hook up the jump button. So we're going to jump and jetpack at the same time is what we're going to do. It's on the Rigidbody game object. Let's go down here. Jetpack, input, that was the name of the method. And I think that's it. That should be it. Let's check it out. See if that works. No, it's not working. Why is it not working? Why are we not working? Oh, no, it did work. Oh, it's because I was just clicking. Was it because I was just clicking jump? Yeah, it's because I was clicking jump, duh. I have to hold jump. Because this is Jetpack, of course. Yeah. Now let's just actually double check that it's not jumping high. Yeah, jump is set to 1.5. So this is the Jetpack flying up. Cool, so I can hold jump. Right, this is my Jetpack component. And notice that I think there's one setting I forgot to mention earlier. Notice that the character is not rotating, like when I'm moving. That's the default value for mesh for this velocity yaw animation, but I do have a bool right here during free fall, like we want to apply this during free fall. So now it will rotate in the direction of your velocity during free fall. And then, I haven't tried this yet, but I wanted to, let me see here. Let's do this. Let's do a serialized field Unity event type bool jetpacking. How about like that? I don't care that that's spelled weird. What I'm trying to do here is I'm trying to get a Unity event which will, fire off a bool whether you're starting jetpacking or finishing, and I'm going to get an effect, a particle effect in there. I'm going to use one of Unity's free ones from their particle pack on the asset store and see if I can get a particle showing up. That's pretty fun when I get that going. Yeah, before we assign the value, we grab the old value, and then if they're not the same, then we're going to fire off this event. I really think that'll work. Let's check it out. Awesome. Okay, let's go to Rigidbody, Jetpack. Okay, so let's find the spine and attach, or upper chest rather. Let's attach a cube. That'll be our mock jetpack. Let's see how this looks when he's just running around. Oh, yeah, okay. The camera got mad because this has a collider on it. Let's remove that collider. Okay. Ah, that's so cool. Oh, that looks awesome. That's so cool. Yeah, okay, cool. So let's go into the Unity Technologies particle pack, effect examples, fire and explosion, prefabs, flame stream. I think I was checking this out earlier. I think this one looks pretty cool. Yeah, that'll be awesome. Okay, so actually, yeah, let's just throw it in here. Go back to the hierarchy. We'll child it under that cube. Whoa! Is everything okay over here? Must be the scaling that's all messed up. I think that'll work. Something like that. It'll probably be all right. To 0. Oh boy, that's freaking out. Okay, I think I got this thing working. I think it was just that this had collision turned on. So once I turned that off, it kind of worked a little bit better. So let's just walk around with that, see how that looks. That's okay. It's okay. Maybe these embers need to be smaller. I don't know. Make those a little smaller, maybe. But anyways, point being, we can go to this Jetpack, pop open this Unity event, grab this flame stream effect, and then go to game object, set active. So when we're jetpacking, this will be set to true, the game object's active state, and then when we're not jetpacking, it'll be false. Theoretically, that's what it's supposed to do. Yeah, it seems to be working. I don't know that this particle effect is exactly perfect for this. I'm sure there's a lot of settings we could adjust there. That's kind of cool. Got this working fairly quickly. Yeah, we could for sure get the particle looking better with this. That's pretty cool though. Maybe if we make this jetpack a bit weaker, that might be more reasonable. About 30. Yeah, and then that view again. Sorry, the mesh, this velocity yaw animation. Let's turn that on. So now wherever we're headed. Yeah, that's pretty fun. I'm gonna meet you up there, dude. I'm coming, buddy. There we go. Okay, so the next thing I wanted to show was this Backstep script. So this Backstep script, this is kind of like a Dark Souls style backstep where like if you're standing still or like Elden Ring and you hit the roll button, you'll do a backstep. So I want to try to replicate that here. And I had kind of gotten this working, and it's fairly simple. This time we are referencing Traversal Pro. We're referencing the character motor component. And you know what, one thing is I normally don't like to do like special, ways of coding or something like that. I like to try to keep things as standard as possible. And then in that spirit, you could just say this, character motor, the concrete class character motor. But character motor implements character motor. I've tried to use interfaces as much as possible, but normally you can't reference an interface in the inspector. So I wrote this struct here, interface ref, and I'll show you. Here's the code for it. And this is not unique to Traversal Pro. There's a lot of people that have done this online, kind of a standard technique, using the iSerialization callback receiver. It saves it as a Unity Engine object, and then you grab it as the interface. So it's kind of a way to cheat and be able to reference an interface in the inspector. That works nicely, I think. So anyways, whether you do it that way or whether you just do the concrete character motor class is totally fine. You could replace character motor with your own if you want and just make sure it implements that interface. And the rest of Traversal Pro should be able to handle that just fine because they reference it as an interface, not as the concrete class, the other components in Traversal Pro. Anyways, so here's Backstep. We set an acceleration. That's kind of the instant, backstep acceleration. And then a cooldown because you don't want to just keep doing it forever. The view, we do need a reference to the view because we need to know which direction is backwards. Rigidbody, because we're going to apply a rigidbody. This is to check our current cooldown. So yeah, we grab the view forward, set the Y to 0, so that way it's kind of a flat horizontal axis that we're working with, because the view might be looking up or down or something. So we want it to be flat, then we normalize it, and then we just add the force in the reverse, the negative, so backwards. Times acceleration, force mode velocity change, so it's like an instantaneous acceleration. And then we reset our cooldown. So that's it, that's pretty simple. Traversal Pro doesn't need to know what you're doing. In this case, character motor is here just to, it's just here to check if you're grounded. That's it. So it's offering you something rather than requiring something from you. in this case. So that's nice, because you don't want to backstep in midair. That would be weird. Let's check it out. We'll go over here to Rigidbody, add in the backstep component. So the motor, okay, so that's just going to be on the Rigidbody. And then the view, we drag in the view, transform. Those should be fine. And then we need to hook up the input. So, and again, I just did the public method, which takes in the input action. Let's do the interact button, because for lack of a better button for now, make it just real simple. Yeah, the component was on the Rigidbody game object. And I may rename this game object kind of the default player. If it may be a different name than this, but it's the same idea. It's the game object with the Rigidbody. So backstep, backstep, input. Yeah, there we go. So, okay, so now the Y button. Yeah. And then, of course, since I'm moving that way, the velocity yaw animation component tries to do that. But then there's the backstep. And we can swap that out. We can turn this off, and we can swap it out for the yaw smooth yaw constraint. Yeah, and of course it's mad because we don't have that. Yep. Okay, so now it should be an actual backstep. And I don't have backwards animation or strafing animation, but we can backstep. There's the Y. On my Xbox controller, it's the Y button, the interact button. When I jump, I thought I turned all that off. Oh, interesting. Oh, you know what? I know why it's still doing that. It's because I disabled the jetpack, but the input method still gets called even if that is disabled. A lot of times in those input methods, I'll check, like, are you disabled, you know, and then don't do the input. I just forgot to do it there. That's from when I first put the component and didn't attach that. Yeah, when I jump, I can't backstep. I'm on the ground, I can backstep because it's detecting if you're grounded. It's asking the character motor, is the character grounded? Yeah, cool. So that's a backstep. Okay, so the next one I wanted to show was beam walk. So this is like if you're walking on like a tightrope or a beam or something. This was kind of the most complex one, like a custom script I tacked on, you know, after the fact. And this is an example of what you might need to do to get some features working for your game. So let's actually set this up. I need to set up a beam. Yeah, and you notice like this is kind of like a bump right there. That's fine. The Traversal Pro doesn't care. It can handle bumps, gaps. It's okay. The capsule collider just slides over it. It's all good. And this beam walk script is not included in Traversal Pro, but I believe I have it. I'm not going to show it right now. It's a little bit more complicated. I have it in the Discord. So if you want this beam walk script, you can go check out the Discord. I have like a how-to there. You can get the script there. Yeah, okay, and then let's check it out. See if that works. Okay, so why is it mad? Oh, okay, I know why it's mad. It's because... Okay, so character motor logged this warning. Character motor logged this warning because I have a Rigidbody in the scene that has a non-1 scale, which is not desirable, and it's this cube. The cube doesn't even need a Rigidbody at all, actually, in this case. I'm surprised it sat there. I'm surprised it didn't, like, fall. Interesting. But it doesn't need a Rigidbody at all. Anyways, let's try that again. Yeah, so this works, okay. So if I push mostly forward, it's going to walk forward. The way that this is working is it is modifying my input. The beam walk script is not applying forces to the Rigidbody. It's grabbing the character motor component and it is inserting a method into the character motor has an event called moving, I believe, and that event gets run after the ground detection, but before forces are applied. And so that's a chance for you to like get in the middle and adjust grounding if you need to, adjust forces or adjust input, whatever you need to before character motor applies forces. And that's what this does. So it gets in there and it modifies the input to where the input is now like, it's going to modify your input so that it's just forward or backward. And then if I move to the left, it'll let you walk off. But if you're mostly forward or mostly backwards, it'll be okay. And then I can turn up this centering strength, and this is like how much it's going to modify your input. So now I'm doing like a full circle on my left stick, the movement stick on the gamepad, and he's just going forward or backward. There you go. Now if I just hold it to the left, he will hop off if I hold it to the left. But yeah, so this is another example how you might implement something. And then while you're on the beam, maybe you'd want to apply a different animation. I don't have any other animations right now, but you could like grab a reference to character run. Character run is kind of just the built-in default component that defines the run speed, which we went over earlier. You could grab a reference to this, reduce the run speed, so that's, the player is forced to like walk slowly on a beam, change the animation, whatever you want to do. It's all pretty modular. Grab references to whatever you want. Oh, what's cool about this is actually you can jump onto the beam too, and that works. So like from over here, I can jump on, and it works. Oh. Oh my gosh, you know what? Let's turn on the jetpack. Let's get the jetpack going. I can jetpack onto the beam. Yeah, look at that. That was cool. Yep, and then I'm still walking forward, backward, jetpack, wherever I want. Oh, let's get on there. Come on. Let's see if I can make it. Oh, it's close. That's tough. It's a tough landing. There we go. I'm on the beam. Going back and forth on the beam. And again, it's not the beam script is not applying forces, just modifying that input. Cool. Now I'm just gonna just screw around here for a bit. What's up, buddy? You doing okay over here? Let's check on the other guy. How you doing, bud? You doing good? There's another script I wanted to show called NPC Follow, and of course this makes the NPC follow the target. The target can be any transform. In this case, it's of course going to be the player. So all it does is it just checks the offset from the target to like this game object's current position, and then it sets the character motor's local velocity goal to that direction times the desired run speed. So let's check it out in action. So we'll create a character, snap him to the ground, and then on the rigid body, we'll add NPC Follow. Okay, and then make sure you get the character. Oh no, whoops, that's not the character motor, that's the target. So let's grab the target here. Make the player's rigid body be the target. And remember, this root game object in the player doesn't move around. So it would be the rigid body that moves around. The game object named rigid body here. Stop distance of 3, that's probably good. Speed 5, that's probably good. Let's see. Okay, so he's looking towards us. You know what it is? You know what it is? It's character run. I think they're fighting because character run is also trying to set the local velocity goal. So let's remove that. There we go. So now he runs towards us. Let's go in the gravity left, buddy. Nice. Yeah, and this is not using any sort of like pathfinding or nav mesh. It's just telling it the direction to run. That's really it. So it's not very smart, but it works for like a super basic NPC thing. You know what's cool is, let's do this. Let's make a bunch of them. They're all inside of each other, so they're going to probably, yeah, like that, explode out like that. But that's okay. Cool. Let's see what it looks like if we grab a couple of them. Sorry, my mouse is controlling the camera. We'll grab 2 of them and increase their run speed. Up to like that, yeah, how about like that? Well, I see one of them. Oh, there's the other one. Yeah, 2 of them are coming out in front. That's pretty cool. Yeah, and you know what? What if we do, for 2 of the other ones, let's set their stop distance to like 10. See what happens. Oh, come on. Yeah, cool. So those 2 over there stay far away. That's interesting, yeah. That's pretty cool. Yeah, so that's NPC Follow. You know, one other quick thing to mention. Some people love root motion. They're using root motion. Root motion probably won't work well with Traversal Pro. I believe root motion it wants control of the transform, and the Rigidbody also wants control of the transform. So they're going to fight each other. It might be possible to get it working. I haven't done any work to get it working in Traversal Pro. You might be able to get it working. Maybe you could do something where like you're, modifying character run speed and acceleration every frame based on like what you expect the animation, would be like doing. You could try something like that, but if you absolutely need root motion, this might not be the best asset. Well, that's it, I think. I hope you enjoyed. Thanks for listening. Hope you enjoyed Traversal Pro. Check out the Discord. The link, I think, is in the will be in the description of this video. It's on the asset store page. It's in the documentation, I believe. You'll find it. Check out the Discord if you need any help, or if you want to show off what you're doing. I'd love to see what you're making. That'd be awesome. Cool. See you later.